All right, so let's take a look here at this equation. We've got a tangent equation. There might be infinitely many solutions, what we expect for this equation, but they're only wanting solutions that are between 0 and 2 pi. So let's get this tangent by itself. Let's subtract tangent from each side. So then that would give me 4 tangent of theta is equal to -1, and let's divide by 4. So we have the tangent of theta is equal to -1/4. Now, if we look at the unit circle, our y/x ratios, we can't find a known value that has that ratio. So we're going to have to use the calculator, a scientific calculator. And this negative ratio is going to return a negative angle measure. It's going to return this. Now we also know up here in quadrant 2, there's a point that has that same ratio. If you take the y-coordinate divided by the x-coordinate, from this point in quadrant 2 and also from this point in quadrant 4, that ratio is going to reduce to -1/4. All right, so when we go to the calculator and have the calculator help us to find this angle measure, it's only going to look on the right half of the unit circle. It restricts this inverse tangent to be a function. So the first value that it gives us is going to be a negative angle measure. We want, of these infinitely many solutions, we want to be between 0 and 2 pi. So let's see what the calculator does give us. We are in radian measure. Let's take the inverse tangent of -1/4 and see what we get. -0.245. Well, we said we want our angle measures to be bigger than 0. So let's see. Let me find a coterminal angle to that by simply adding 2 pi. If I add 1 complete revolution, there we go. There's a solution to this equation, and 6.038 is between 0 and 2 pi because 2 pi is about 6.28. So 6.038. Now that was that angle that was in quadrant 4, right? So we want that angle that also that's in quadrant 2 here. Let's go back to the calculator. If I go back to that inverse tangent of -1/4, rather than getting a coterminal angle, rather than adding 2 pi, if I just add pi, and the reason that works is because the period of tangent is pi. If I just add pi to this, I'll have another solution, and this angle is in quadrant 2, 2.897. So I claim that both of those are solutions to this equation. Let's come in and check. Now this time we'll have to compare the left-hand side against the right-hand side. So if we have 5 times the tangent of, let's check this first angle, 6.038. So the left-hand side of that equation is this. Let's go to float. Let's really carry this out. All right, now if I check the right-hand side of that equation with the same angle measure, 6.038, and it's slightly different, but -1.25, -1.25, And we were expecting these to be a little bit different because we only rounded it to the nearest thousandth. But it looks pretty good. All right, so let's check this 2.897. On the left-hand side, we've got 5 times the tangent of this angle, 2.897. And on the right-hand side, we've got -1 plus the tangent of this angle. And they're not exact, but they're, -1.24, -1.24. It then jumps to 7.9 and 9.5. But it's reasonable, especially with our rounding it just to the nearest thousandth. All right, so of the infinitely many solutions, I claim that these two are the ones that they were wanting. All right, I will talk to you later. Bye.